Introduction. The purpose of this lab was to observe Newton's second law of motion for an object moving at a constant velocity. The experiment was, in my case, I hit a pool ball and observed its motion from the initial hit, or strike, using the cue. In this experiment, the net force is zero as the change in velocity is zero. There are some important equations, and the two equations of note here are the position update formula, as denoted by the final position being equal to the initial position plus the average velocity times the change in time, as well as the velocity formula, which is velocity is equal to the change in position divided by the change in time. Now, the steps for the experiment were as follows. Record a video using the camera phone, insert the video into the tracker software, then collect the data from the tracker software in which you used the point mass feature, and you use that on each frame of the object moving, the object in this case being the pool ball. And then insert this data into Sheets, Google Sheets. It's basically just Excel software. And here is the tracker video. Okay, as you can see, it's just a pool ball going, and the camera has to be static in order for this to work. And here are the GlowScript diagrams. So my GlowScript code is going to be present later, but these are the diagrams that it produces. As you can see, the only mapping movement is in the x direction, because that's the direction of the motion of the ball. In the tracker model, the ball moves on the x-axis, so there's no movement on the y in the y direction. That would only be due to something going wrong in the experiment. You can also see that it's a straight line, which means that it's constant. The velocity is constant, which we know. So the ratio of position to time passed stays constant. And here's the velocity. Once again, you can see it's constant throughout. It doesn't change at all, which makes sense. And then here we have a graph of the displacement versus the time, and as you can see, we tracked the model as well as the tracker, and we calculated the model velocity to be 0.684 meters per second. And we did this using velocity average equals the final position minus the initial position divided by the final time and initial time. The final time being 1 and the initial time being 0, so you get 1 in the denominator, and then the initial position is going to be 0, and the final position is just going to be 0.684, and that's how you get 0.684 meters per second as your model velocity. And as you can see there's a difference in the final displacement between the experiment and the model, which means that the experimental velocity may have not been constant, which would only be down to being in a mistake on my part. Something could have gone wrong somewhere in the procedure. And then here's the GlowScript code. If we edit this program, you can see the code right here. Two important parts right here are changing the ball velocity right here in the position of the ball. We have to add the velocity of the ball and multiply it times the change in time, and then to calculate the position and then the velocity, we have to add the net force and then divide that by the mass of the ball. So if we go back here to the presentation, I'm sorry, 1 second. That's actually going to be it. Thank you.